be even a little tougher. So we're solving equations in chapter 1. Equations and inequalities. And there's just all different types of those. Okay, so notice that everything we did in chapter R did not contain an equal sign. We were just factoring and moving things around, using exponent rules, simplifying problems, but we never solved anything. We never said like x equals 2. You know, nothing was solved, just simplified in chapter R. So whenever you start out, number 13, we see a difference. There is an equal sign. And whole bunches of variables. So we can't really solve for that and get a number answer. It's all just variables there. But we're going to rearrange it in terms of n. Get n equals. Solving in terms of n. Okay, first thing I want you to think, in anything that has an equal sign, if you see a fraction, you're going to clear that fraction. Just that's automatically, a lot of times students, if you can get rolling on a problem, then you just keep rolling. It's just getting past that first step. So just think, first step, if I see a fraction, figure out how to clear that fraction, which usually means timesing through by the LCD. This is over 1 right now, so this is the only denominator. So I'm timesing through by this combo, that's the binomial. It still counts as a term, or as a factor. So there it would be, times on to this, would wipe that out. But then we'd have to do it to the other side to keep it balanced. So we'd times nr plus r on the left side. Again, on the right side, its purpose was to cancel out that fraction and just leave ne. On the left side, it times by the I that's there, so it will distribute. But for now, let's just say it's nr plus r, that quantity, that binomial, times the I on the left side. All right, my goal is to get n solved for. I've got n in a couple of places. One thought might be just divide out that e and be done, but there's still an n trapped over on the left side. So that's your big battle. You've got to get these n's together. 2 different n's, 2 different places. You've got to bring them together. So I would distribute to get this n out. nr times I, and then I times r. Again, I said you have 2 places that has an n. So if they're in 2 different terms, you've got to pull those together somehow. Either take both ends to the right or bring both ends to the left. It's up to you, and I want to talk to you about that because it makes a little difference in how the answer looks. They're equivalent, but they may look a little different, so you need to especially notice this. I'm going to decide to take my ends to the right side. So bringing this across, I've got ne already there, minus inr, and an ir left on the left side. Because there are 2 n terms, if I could, I would combine those. Like if I have 2x and 3x, we combine terms and say 5x. But these do not combine, so my other strategy is I factor the n out. There's a common n, factor that out. It leaves e minus ir equals I capital R. And now this n is times on to that quantity, so I will divide that out. E minus ir cancels that out. Do the same thing to this side. And n is now alone equal to IR over, yes, E minus IR. Read my writing. Okay. Now, see if that's a choice, because it may or may not be, depending on which direction they move their n terms. And it is choice D. But it would also be appropriate to say that this is equal to negative IR over I little r minus E. This is the answer I would have got if I would have decided, let's see, where was it? Up here, if this step, I would have decided to bring my ends to the left side, or sorry, to the left side. If I would have brought the ends to the left side, I would have factored out the n. IR would have went to the right and been negative, so I would have had a negative IR, and every sign would have been opposite. Everything would have been opposite directions. So all the signs different. It's like a negative times on the top and a negative times to the bottom, which is okay. Timesing everything through by a negative top and bottom keeps the balance. So this would be equivalent to this. Every sign is opposite from the original. All right, so any questions on that? Can you read it down to the bottom? I'm sorry, I'm getting so long problems on this chapter all in one. So it takes up from the top of the board to the bottom. All right, number 14. The chemistry problem, the solution type problem. Oh, shoot. You need me to come back over here? The mixture problem, what you're doing on these, the typical mixture problem, we've seen this a lot in class, is you're trying to either strengthen a concentration or you're trying to dilute it down. But you have different concentrations in two containers that you're pouring into a third container. So a lot of times you've seen me make these three containers. Think of them like as beakers in chemistry class or something, or just some sort of container. You're pouring these two things into the output over here. So you've got a concentration percent and how much the container has in it. So a capacity and a percent in each one of these as you go across. All right, so reading through, they're usually pretty easy reading to just put them in order here. It says in chemistry class you've got 9 liters of 4%. That's your first container. That's 9 liters in it. That's the amount. And it's concentrated at 4% silver iodine solution. Then we're going to mix it with, so that's your clue, you're going to add and go to the next container. Mix it with 10% solution. It does not tell you how much is in that next container. That actually is your unknown. It says how much of that do you need. So how much of this next container, so X amount that's concentrated at 10% to get, that's your clue to make your equal sign, to get the output of 6%. Now if you miss this one, I've noticed that it's usually this detailed. Sometimes we forget that there's an output amount that goes here. We have amount percent, and we need to have how much of that percent. You know, a percent doesn't mean anything just hanging out by itself. If I say 2%, 2% of what? 2% milk fat, 2%, you know, on your test, 2% of what? So you need an of what? Anytime you have a percent, you got to have some number up there. So make sure you get your amount here. And your amount is these two things were poured into this, so it should be 9 liters plus X liters. So 9 plus X is your amount there. And then that's basically your equation. You take 4% times 9, multiply your amount times percent in your first container. 10% of X, so 0.1 or 0.10 of X, needs to equal 6% of the two combined to get this thing to come out like they're asking. And then you can pull the decimals right back out of that if you want. You can times through by 100, because there's a decimal in every term. Times it by 100 moves the decimal 2 places in every term, and that's allowed as long as you're keeping the balance doing the same thing to each side. So again, that's optional. I know a lot of you all don't do that step and just deal with the decimals, and it's not a big deal. So that either way is fine, but that is an optional. Probably if you were reading Math Excel, I think they would probably do that. So it's 36 plus 10x, distribute here, it's 54 and 6x. Get your x's together, so minus 6x is 4x, 36 across minus 36, oh what is that, 18 maybe? Divide by 4, and x is 18 fourths, which will be 4.5 maybe, 4.5 what? 4.5 is the x value, the how much we needed at the 10% concentration, so 4.5 liters. Okay, any questions on that?
What? Yeah. What?
All right, maybe we can do one more before our time is up, unless you want to stay with me a little longer. I may continue on and work a few more problems, so if you can stay later, feel free to do that. Okay, number 15. Number 15 is going to be similar to what we did here, only it's not quite the mixture problem, but it is based on percents. You've got 2 money accounts, and you're trying to get an output over here, how much interest you want to earn. So we're trying to get some interest in this first account, plus some interest in the second account to equal out to a total amount of interest in the third account. So how do you get interest? Assuming it's just simple interest, it's principal times the rate times the time. This problem is based on just 1 year, so time will not really show up. It's just times 1. And there will be a clue for the principal, and the rate will be given. Okay, so the interest in this account, we need to know how much principal we're investing. And then the same thing, principal and rate, to get the interest here, and then the total. It says you need $2,900 from the 2 accounts. So it gives you how much money you want over here. Notice we don't have 2 pieces on this one. We don't have a percent hanging loose here. It's already multiplied together in interest form. So there's just one thing in that last box. All right, so the clues say, Roberto, he invested some money at 7%, and then he invested $2,000, more than twice that amount, at 10%. So he has a 7% account and a 10% account, and then we have some clues for how much money he puts in each. Did not tell me how much at all he put in the 7%, so I'm going to call that my unknown X. In the other account, the clue is it's 2,000 more than twice whatever that is. So 2,000 more than twice X is the clue for that principal at 10%. So we got principal times rate. That will be multiplied together to give me my interest in my first account. Principal times rate multiplied together. 10% of that principal. This interest plus this interest is supposed to total $2,900. And then you would distribute, or you can use the trick to times through by 100. Like I said over here, if you times by 100, perfectly allowed to do that. I've noticed that most of my students don't mess with this step, and that is absolutely fine. It is just usually the method that's explained in the book or on Math Excel. Just notice, though, if you do times by 100, it moves that decimal over 2 places. It moves that over 2 places. And then don't forget, you have to times both sides. Even though it doesn't look like it needs it, to keep the balance, you have to move its decimal 2 places. So it adds 2 zeros onto that. So 290,000. And then you distribute and solve. That gives you 27 X's. We throw the 20,000 across the line. 270,000. Divide by what's with the variable, divide by 27. The 27's reduce and you have 1 and 4 zeros. 4. So $10,000. That means always go back and see what you let X be. That means you're putting $10,000 in your 7% account. Okay, big deal here though. Notice the question is how much was invested at 10%? And also notice 10,000 is not a choice, so you know something's up with this. It's not a choice. So $10,000 is just what X is. The question is how much at 10%, so that's 2,000 plus 2 times our 10,000 we found. So 2 times 10,000 is 20,000 plus 2,000. The final answer is $22,000 invested at your 10% account. So that is answer C.
Second time at 10,000.